Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to explain on normal distribution. This normal distribution belongs to continuous random variable, which is we already learned in general in chapter 1. Okay, this is most basic for the continuous random variable. Normal distribution actually very important in statistics as it frequently used in statistic analysis. And for your syllabus, okay, this normal distribution going to be used in the next chapter and also until the last chapter. So please make sure that you are really understand on this normal distribution. Okay, first of all, we have to look at the properties of this distribution. Okay, since it is continuous random variable, okay, so means that it can take finite number. Okay, any number between the two exact value. So what we have learned in chapter 1, for a continuous random variable, it normally will give a PDF function. Okay, so there are many types of PDF function. But now when you look at the normal distribution, okay, that is a specific distribution, so it has a specific or special PDF of its own. So this is the PDF. Means that what from chapter 1, if we want to find the probability of continuous random variable, so we need to integrate the PDF. But since this normal distribution we always use, so we use the standard normal distribution instead of its own distribution. Means that we standardize the distribution before we calculate or find the probability. So for normal distribution, the parameter involved is mean and the variance. So this is the two parameters that will define how the distribution shapes. Okay, so from these two parameters, it will change the PDF. So there are some properties of normal distribution that you must know. So x can take any numerical value since it is continuous random variable, and then the distribution shape is bell shape, which is it is symmetric, and then the middle on the bell shape is the mean. Okay, so the mean is in the middle, and then we have the bell shape which is symmetric. So means that the area and on the left and the right is the same. The total area under this bell shaped curve is 1. Okay, so it fulfill or follow the properties of random variable that we have learned in chapter 1, which is the summation or integration of the PDF on the all possible x, we will obtain 1. Okay, so if we integrate from negative infinity until infinity for the PDF, we will get 1. So since it is symmetric, means that the area on the left hand side is 0.5, and then on the right hand side also 0.5. For mean, mode and median are equal, which is on the middle of the bell shape. So means because it is symmetric. And then when you draw the curve, this curve will never touch the x-axis. Okay, so just like flying there. And then for calculation, so we will standardize what I have said just now. Okay, so we use the standard normal distribution. So from the PDF here, which is we have mean and standard deviation according to the particular random variable of normal. So instead of use this PDF, so we will use the standard normal distribution. So how we are going to standard the normal distribution? So this is the formula. So instead of using x, now we're using z. So z means the standard normal distribution. So x from the variable, okay, we minus the mean and then we divide by the standard deviation. This is the normal distribution, standard normal distribution in the Modox table. Okay, so this is the PDF just now, and then okay, this is how the probability is calculated in this probability. So it will give you the probability or the area under the curve on the right hand side. Okay, in the middle is 0 because now it is a standard normal distribution. So this is the first decimal point, and then this is second decimal point. Means that if you look at this one, okay, this is 0.13. Okay, so this is the probability when the Z value is 0.13. Okay, so the probability is 0.4483. So all value in this table, inside this is the probability, and then this is the Z value, not the X. Okay, let's have example. Okay, if X is distributed with according to normal distribution with mean and variance, okay, we write this way. So for this particular X, it can take any number of mean and variance, okay, according to the distribution. Okay, so instead of use this normal distribution, we will standardize by using this formula. So once we have standardized, we write it as Z distributed as normal with mean 0 and variance is equal 1. So once we get this value 0 and 1, mean 0, 1 for standard deviation and also the variance, so we call it standard normal distribution. So once we get this one, so then we can use the Murdoch's statistical table. Let's look at this example. Given X distributed according to normal distribution, given that the mean is 10 and then the variance is 23.5. Okay, and then we want to find the probability of X greater than 2. Okay, so before we use the table, the statistical table, we need to standardize this. Instead of using Z, now we want to change it into Z. So we use the standard normal distribution formula just now. Z is equal to X minus the mean divided by the standard deviation. So please remember this formula. Okay, we're going to use this frequently. Okay, so this one X, okay, now we change it into Z. Okay, so by using this formula, so X now is Z, then you follow the sign here, it is greater than, and then X is 2. Okay, so X here is 2. 2 minus the mean is 10, and then divide by the standard deviation. So we square root the variance, because when we write down the distribution, here is the variance, but when we want to standardize, we use the standard deviation. So you square root the variance. Okay, so X minus mean divided by the standard deviation. So we obtain X greater than negative 1.65. You can take negative number for the Z. So before that, from the standard normal distribution, okay, it is bell shape, and then the middle is the mean. Okay, then the area 0.5 here, 0.5 here. Okay, it is symmetric, and then around here the x-axis is the Z value. Okay, so this is the normal standard normal distribution. Okay, on the left hand side is the negative number or value. Okay, on the right hand side is the positive value for Z. Okay, so now our value is Z negative 1.65. Okay, here is the middle, mean is the 0. Okay, according to this. Okay, mean 0, the variance is 1. Okay, so negative 1.65. Okay, it is around here maybe. Okay, negative 1.65. Okay, so it will be smaller around here. Okay, on the left hand side on its end, but it never touch the x-axis. This one also, the negative, the positive will be increasing, but normally up to 4 it will nearly 0, which is the area. Okay, so refer to the Murdoch's table just now. Okay, you can see here that when the Z value, okay, nearly 4, the probability is very small here. Okay, you can see here for 4.0, the value of the probability is 0.00003. Okay, so means that the area here is very small. Okay, when it's nearly 4. Okay, so we want to find this probability, and then okay, this is the value of z, which is negative 1.65, and then we have to decide which part we want to find the probability, because the area, okay, it will equal to the probability that we want to find. Okay, so in this case we want to find greater than negative 1.65. So greater than means that on the right hand side. Okay, so greater than negative 1.65. So means that if you draw it again, okay, so it is 0, so negative 1.65. Okay, the property, I recall that. Okay, here is the negative 1.65. Okay, the positive is also, we have the value, the same value. Because it is symmetric, means that the area here on the left hand side and the right hand side is the same, because it is symmetric. Okay, this is the case when the probability of less than negative 1.65 is the same with greater than 1.65. Okay, so this area means that probability of x less than negative 1.65. Okay, this one. And then on the right hand side, this should be z. Z greater than 1.65. Okay, be z here. Okay, so this is symmetric. Okay, less than negative 1.65 is the same probability with greater than positive 1.65. Okay, so you have to be very careful on this part. So I suggest you to draw so you can see which part is equal or symmetric. So this is on the right hand, left hand side, and right hand side is equal. Okay, now back to this question. Okay, so we want to find this area under the curve. Okay, this is not stated in the Modox table because it is negative. Okay, remember that Modox only give the positive value of z. Okay, the probability of z. Okay, so we need to use this normal probability properties. Okay, we know that the area under this curve, if we integrate the curve, the PDF, then we will get 1. So means that here all 1, then we want to minus this area, which is we don't want to include on this part in the calculation. Okay, so means here instead of finding greater than negative 1.65, okay, we can find it through 1 minus probability of z greater than 1.65, because this area we know already that it will equal on the right hand side, which is this one have in the table, the probability here. Okay, on the right hand side, this one we cannot find it in the Modox table. Okay, but on the right hand side, yes, but it is symmetry. So 1 minus, okay, this one we refer to the table. 1.65. 1.65 is here, right? 0.0495. Okay, we substitute the probability. Okay, 0.0495 to 0.95. So this is the probability of this one, this area. So once you get the final answer, please check whether it is make sense or not. Okay, so the answer now is 0.95, and then okay, you can see here that this area is 0.5. Okay, we already know, but this area we don't know the value, right? So means that the probability must be greater than 0.5. Okay, so we check back, okay, whether it is make sense or not. Okay, so in this case it's okay, okay, because it is greater than 0.5. So the probability is in here, okay, it should be less than 0.5 because it is less than the half of the bell-shaped curve on the one side. Let's look at this some example on the normal distribution. Okay, this is greater than 3.1. So if you draw the curve, in the middle is 0, so positive is on the right hand side. So here 3.1. And then you look at the sign. The sign is greater than, you shade on the right hand side. So we want to find this area. Okay, the probability is in this end of the right hand side area. So here we can directly find the probability by using the Modox table. Okay, this is no problem. And then let's look at the second example. probability of 2.85, and then it is on the right hand side, it is positive, and then look at the sign less than, so less than, it is on the left hand side, so means we want to find this bigger area. Means here that we need to do just like the previous example, 1 minus the probability of greater than, this is Z, 2.85. This one we have the value in the table, so before you use the table, make sure that the sign is greater than and then the value is positive, the Z value. And then for this one, 2.2 negative. So negative is here on the left hand side, so 2.2, and then the sign is less than, so you shade on the left hand side. So this one we don't have the value in the Modocs table, but we know that it is symmetric, right? Symmetry on the right hand side, which is the positive value. This is negative less than, it is equal with the positive greater than 2.2. So this part we have in the table, so means that it is equal to Z greater than 2.2. So directly take the value of probability in the table. Let's look at this E. It is positive and positive, both positive. So 1.72 is on the left, 2.76. Make sure you put the value in correct order. So means that the smaller value must be in here, near with 0, and then it will become greater. This is more positive, so this one is greater than this 1.72, so it should be around here. So make sure you state the correct value. So how are we going to get this area? So you have to manipulate the table, just like what we have already learned in the previous two probability, which is the binomial and Poisson. So what we have to do is we find the area. 1.72. 1.72. I always draw this in the middle because we want to differentiate between the left hand side and the right hand side. So you know this is positive and then this is negative. So this area, and then we minus the smaller area, which is the 2.72. This in the middle 0. So this area minus this at the end, so we get in the middle. So this is probability of Z greater than 1.72 minus Z greater than 2.72. So we will get the probability in the between the two value. So when you calculate the probability and after you find the value in the table, so make sure it is makes sense again. So this after you minus should be not negative number because it is probability. So this one should be greater than this one, the probability. Then this one. Next question. G, both negative. In the middle 0, and then negative 1.89, and then negative 0.24. So in this area in the middle. So this is the same actually with this one, but this is the negative value. So you transform it into the right hand side. We will get the same value because it is symmetry. So I hope that you don't confuse. I put in the same graph. Here must be the 0.24 positive, and then here is 1.89. So here same with the previous question. So means that probability of Z greater than 0.24, Z greater than 0.24 minus Z greater than 1.89. Okay, so 0.24 here minus 1.89. So it means that here is more, the probability is larger than this one. Okay, so we minus the probability. Okay, so this is can be directly take from the table. Okay, make sure the sign is greater than before you refer to the table, and then the Z value must positive number. Okay, so hopefully you can see other example. Okay, on your own and try it yourself. You can try on this kind of problem. Okay, it's just give instead of just direct question, so it give the case study, so it's just the same. Okay, so if you understand the principle, should be no problem on this. Okay, and then instead of using the model table, we also can find the probability of normal distribution by using the calculator. Okay, so this manual is for this to model only, but you can always find it other if you use other models, so you always can find them in YouTube, for example. So there are a lot of tutorial there, so you can find yourself. Okay, so it's very simple actually. Okay, so you can follow step by step here. Okay, but you should remember that you can use P, Q or R. Okay, the option we can select the option. I always suggest my student to use the last one, R, because this is the value which is similar with the model table, so you will not get confused. Okay, so R, but it's okay if you want to use P or Q, but make sure you really understand it. Okay, so R is the probability which is just similar with the model table on the right hand side, and then the Z is positive. Okay, so you can try on by using calculator, because it is more time saving when we use calculator instead of table, and also it's more accurate because we can put in more than 2 decimal places point. Okay, please try other example, and then if you didn't understand anything, you can always ask me in the group WhatsApp. Thank you. Bye. Assalamualaikum.